Okay, we're going to cover selection statements. So the first thing to start with is the Boolean type. So Boolean is the last of our 8 primitive types and holds a value that's either true or false. And it's not directly convertible to a numeric type. So when you're trying to encode something, let's pull this out for a second. You have a type Boolean, you say Boolean B equals just false. Then if you ask computer to print it out, it's going to get printed out just as that word true or false. If I do that, it's false. If I assign it the value of true, same thing, it's going to get printed out as true. Okay, so just like the other primitive types, if we want to declare it, we give the Boolean and then the variable name. So B is going to be a variable of type Boolean. Again, it can hold the value either true or false. And when you're assigning values, you can use literals, like you can just write out the word true or false and assign that to B, or you can give it the result of some expression. For example, if I have an int x is 0 and an int y equal to 1, the expression y is greater than x, since y is 1 and x is 0, that resolves to true, and so I'll assign B the value of true. For example, I can do this in my code here. I say Boolean B equals 1 greater than 0. Well, of course, 1 greater than 0 is true, so when I run this, B has the value of true. Okay, now, simplest Boolean expressions is just going to be a true or false literal, but typically a Boolean value results from one or more equality tests or comparisons. So, first thing, objects have an equals method, right? And for most objects, any object can override the basic one, but typically the way it's implemented is to check if the objects have the same data member values. If so, they're considered equal. If not, they're considered not equal. For primitives and for objects, you can use a double equals sign to see if two things are the same, but it works differently. So for primitives, the double equals operator resolves to true if those two are the same value and false otherwise. For example, I could do this. Is 1 equal to 0? Or is 1 equal to 1? Well, of course it is. That'll give true. 1 is equal to 1, right? Likewise, 1 is equal to 0 is false. 1 does not equal 0, so that gives false. With objects, it works a little differently. The double equals operator resolves to true if, in fact, the objects are the same object. Now, in particular for strings, this can cause some confusion. So, I'll give an example. Suppose we have two strings, s and t, and we've both created them from literals, from the same literal with the same text. So s is text, t is text. Now, in that case, remember that literal strings are stored in the same place in memory. So text is stored somewhere in memory, s references that location, likewise t also references that same location. So when I use the equals method to see if s equals t, that's going to resolve to true because they both have the same text. But when I use the equality test, s double equals t, that's going to return also true because they are the same object. So if I run this, they're both true. However, if I do string s equals new string text, okay, new strings are created in a different place in memory than literal strings. So again, they'll still have the same text, so s dot equals t will be true, but s double equals t will not be. Okay, so if I run that, same text, true, same object, false. Okay, they're not the same object, they're not stored at the same place in memory. So again, primitives, the double equals operator just checks if the values are the same. For objects, the double equals operator checks if the two object references point to the same location in memory. Also, common bug, remember, double equals for equality tests, but a single equals means assignments. A very common, easy mistake. Now, Boolean expressions can use all the standard operators like greater than or equal to, less than or equal to, or less than. But these comparisons only work with numeric types. It doesn't make any sense to see, for example, is s less than t? Okay, in fact, if you try to do that, you get an error. It says the operator less than is undefined for the argument type string. It just doesn't make sense to say is text less than t. You can test for equality, you can test for a match, but you can only do greater than or less than type things with numeric variables. Okay, note, quick way to remember, because people often forget whether it's greater than or equal to or greater than. Anytime there's an equals involved in the comparison operator, the equal symbol will always come last. And that's true even if it's a double equal symbol, right? It's first and last, so it doesn't really matter. But greater than or equal to, less than or equal to, the equal symbol comes last. Okay, another thing with Booleans, you have logical and or expressions. So the and operator tests whether two Boolean expressions are both true. So if you have two Boolean expressions A and B, that's going to resolve to true if both A and B are true. If either one or both are false, then A and B is false. I'm going to do a simple test with that. Let's say here Boolean A equals 1, which is true. Boolean B equals 2 greater than 1, which is also true. If I do system.out.println A and B, that will, of course, resolve to true because both of those statements are true. But if I change one of them, for example, I change this 2 as less than 1, which is not true, right? Then it's not going to work anymore. It's going to give me false because one of the statements is false. Doesn't matter which one. They both have to be true for an AND operator test to resolve to true. Likewise, you have the logical OR operator. Logical OR operator tests where either of two Boolean expressions is true. So A or B is going to be true if either one is true. If they're both true, that's also true. The only way an OR operator gives false is if both things are false. So if I do here with my OR operator, okay, save that, run it. The first one is true, the second one isn't, so it resolves to true. But if they're both false, for example, like I do 1 is less than 1, which cannot be true, then they're both false, and I get false. Okay. Likewise, Java has a not operator, an exclamation point, which just toggles true and false. So if I do not true, that evaluates to false. If I do not false, that evaluates to true. So if I do Boolean A equals not false, and Boolean B equals not true, and then I can write here, and I'll do the same with B. So since A is not false, it's going to be true, and since B is not true, it's going to be false. A is true, B is false. Okay. Now, it's worth mentioning that by using not, you can always convert an AND expression to the equivalent OR expression and vice versa. I'll save that for a different time. One more thing about Booleans before we get into some of this order of operations stuff. Java uses something called Shortcircuit Evaluation, which streamlines evaluating ANDs and ORs. So imagine for a second you have a long sequence of try to evaluate A and B and C and D. Okay? In principle, you might have to resolve all of those Boolean expressions and say where A, B, C, and D are Booleans. Okay? But suppose, for example, you know A is a very easy test to do, right? And you know that if anything's going to fail in this system, it's probably going to be A. Chances are B, C, and D are all going to work. A's the one that is going to fail for most users. So you might test that one first. And you know that if A is false, then the whole expression is going to be false. Well, to allow something like that, Java uses what's called short-circuit evaluation. And it's only going to evaluate enough of the code to evaluate the Boolean expression. For example, if you have a false in an AND expression, then Java's going to know, right? I can just look at this one. I know if this is my Boolean expression, if A is false, the whole thing has to be false, because in an AND, all of the expressions have to be true for it to be true. So I evaluate A to false, and then I don't have to evaluate the rest of the Boolean expression. Likewise, if I have an OR expression, the entire expression will evaluate as true as soon as I find one true Boolean. So again, if I have A, B, C, and D, A, B are all Booleans, and I have this OR expression, if I evaluate A and I find that A is true, I don't have to evaluate any of the rest of this. I know this entire Boolean expression is going to resolve to true. So, in practice, the point of this is you can do logical tests so that it all happens faster, whether that means more computations can be avoided, or whether it means you don't have to call other devices in a network or consult databases, things like that. Whatever is going on with your system, you can structure these kind of complex logical tests to happen faster. Next thing, order of operations. So the short version with that is you can't do any logical tests until the values involved have been resolved. So if you have some expression, some Boolean expression like Boolean B equals 3 times x is less than 4 plus y, you won't be able to evaluate this until you know what this side is and what this side is. The math always has to happen before the comparisons. So that's the next part of the order of operations, is after you've done all the math, right? First you do the multiplicative, then you do the additive operations. Once those are done, then you can do the Boolean tests. 1 second. I'll be right back. Okay, and we're back. So, have to test those arithmetic values before you can do the Boolean comparisons. Likewise, you have to evaluate the Boolean expressions before you can evaluate ands or ors. So, for example, if we have some big Boolean complex operation, Boolean C equals A and B, where both A and B are Booleans, you can't evaluate C because you can't evaluate this expression until you know whether A and B are true or false. So, order of operations, math first, then relational operators, then logical operators. Okay. Now, that's it for Booleans. So this is a good break point to take a moment, wander off to the fridge, get a snack, whatever, come back with your head clear. We'll talk about ifs. So, if statements are your basic branching statements. You use them to check what you do if something happens when a condition is true and you want something else to happen otherwise. So if you just have an if by itself, all that means is something will happen if the test is true, otherwise nothing's going to happen. So basic syntax for that, you have the word if, then in parentheses you have some Boolean expression, and then afterwards you have one or more statements in what is called the if block. Now, if you have a single statement in your if block, you don't need the squiggly brackets, but if you have more than one statement, you have to enclose them in squiggly brackets. Basic way it works, if this Boolean is true, you execute the statement. This Boolean is true, you execute these statements in the if block. And if it's not true, if this Boolean expression isn't true, then you just skip over the statements. Likewise, if this Boolean is not true, if it's false, you skip over the if block. Very simple. You can also do it with else's. So an if-else is a combination statement, and you use an if-else to check if you want different things to happen if the test is true, you want something else to happen if the condition is false. So when you set up an if-else, you say if the condition is true, only the if block executes, you skip over the else block. If the condition is false, then you skip over the if block and execute the else block. Same as with ifs, if you have a single statement else block, you can omit the enclosing squiggly brackets. So, a little bit confusing sometimes, but an else statement is linked to the immediately preceding if statement in the same block. In fact, an else can't even exist independently of an if statement. So, if you have if, test, right there, else, something, basically, if this Boolean test is true, execute what's in here. If it's not, then you're going to execute what's in there. So this else is always paired with the preceding if. That's true even if, for example, you have an if statement inside the if block. If test2 okay, so within the same level of brackets, this else is paired with this if, right? It's paired with test 2, but this else is still paired with the first test. Okay. So, sample code, here's some cases. In this case, both linkages are the same. So here we have if x is greater than or equal to 0, prints out non-negative. Otherwise, print out negative. So this else very clearly is paired with this if. Over here, we have an if checking if x is at least 0. Well, we set the string positive if as a default option, but we also check subsequently if x actually equals 0, then we set s to equal 0 and print out s. Otherwise, we print out negative. Okay, so this else is not paired with the if inside the squiggly brackets. It's paired with this if that was first of the test. So if x is at least 0, blah, 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 blah. Otherwise, do something else. Okay, and it looks very clear. If you eliminate all this code from inside the squiggly brackets, and it's very clear that this else is paired with this if. Okay, works the same in either case. Likewise, you can nest if statements. So, an if statement is binary, so you can only check for the case where it's true, the case where it's not true. If you're looking at more than two options, you have to nest if statements to do it. For example, I have some pseudocode here. I look at what happens, what I'm going to do as far as taking a trip. So, first check, I see if distance is greater than walking range. If distance is greater than walking range, then I know I'm not going to walk, I'm going to take some sort of vehicle. So then I have two cases. If it's not raining, I take the convertible. Otherwise, I take the SUV. On the other hand, this else, which is the counterpart of distance and walking range here, I know if this was false, if distance wasn't greater than walking range, then it's less than or equal to walking range, and the assumption is I walk. So at that point, I do another couple of tests. If it's not raining, I leave my umbrella at home. Else, I bring the umbrella. And in either case, I walk. So that allows me to cover 4 different cases, because within this if, I have another if else, so that's 2 separate cases. And within this else, I have 2 separate cases. So 4 outcomes total. But anyway, you need multiple ifs if you're going to look at more than 2 outcomes. Last thing, switch statements. So switch statements are used for non-binary outcomes if you have like a whole, more than 2 options. When nesting ifs is cumbersome. So one thing you'll see, if you have like a long string of ifs that you want to test for like 6 or 10 different cases, you don't really want to usually do that with ifs because it's tedious and it's easy to make mistakes when you first write the code or when you edit it. Generally, switch statements are better for that. So when you're switching, you have some input, and based on that, you control where you enter the switch block. So we'll get a little syntax for that because it's a little bit hard to understand at first. So suppose you have some variable that you're switching on. Say it's an int, it's a number. The case lines here represent where you enter in the block. So if this variable matches value 1, you enter the block here. If it matches value 2, you enter the block here. If it doesn't match any of these values, 1, 2, or all the way to value n, then you enter in at the default block. Now, cases specify the entry points. That's all they specify. The case word, other by itself, other than that, is not executable code. It's just pointing out this is where you'll enter the switch block for a particular variable value. Likewise, there's 2 ways to get out of a switch block. Number 1 is with a break statement. A break statement says, I'm done with here with this switch block. I'm going to exit and go out and be done. The other way is, of course, if you just reach the end of the block. And then, so at the end of this default one, even if I didn't have this break here, I would still exit the block at that point because there are no more statements in it. So, only 2 rules you need to know for switches. The case will specify the entry point, and the reserved word break will specify the exit point. So, back to the slide before. For the test, you can use numbers or strings. You can only check for exact matches, and any potential outcomes have to be contained in the switch block. Right? You don't have to cover all cases, but only the cases that you provide will be entry points into the switch block. So, for example, let's do a simple case here in code. So, I have int x equals 4, and then I'll do a switch on x, And I'll say case 0, print 0. I'll do system.out 0. Okay. And that's it. I'll do case 1. I'll do the same thing, system.out print line 1. So, okay, when I run this, x is 4, so I don't have an entry point into the block. So what happens? Nothing, right? I actually don't have anything to print to the console, so it ignores it. So I'll do it here at the end. Say done. Okay, so when I run it, I didn't enter the switch block anywhere because I didn't have an entry point, so it skipped it. But if I set x equal to 0, what's going to happen, since I don't have a break, I'm first going to execute this first line, then I'm going to execute this second line. So it's going to print out 0, and then 1, and then done. If I run this, 0, 1, done. If I want to just have it print out 0, do break, and I may as well do a break here. Okay, and then I only print out 0 and done because I exit the break. I exit the switch block after case 0. So, couple examples. So here I have credits. Credits I call from some external method. I get the number of credits that a student has. So I run a switch on that. I divide credits by 30. So suppose credits are 91. What happens? Well, 91 divided by 30 in Java is going to be 3 because we dropped the fractions. So immediately I enter in the block at this point. My string S is senior, so that's it. S is senior. And I break and I'm done. But if credits are only 1, what happens? 1 divided by 30 in Java is 0. So I enter at case 0, but there's no break. So I proceed to case 1, and I proceed to case 2, and I proceed to case 3. And at the end, S will actually have the value senior. If I want to fix that, I need to put breaks after all those statements like I do here. So in this case, I'm nesting an if statement in there. So same kind of thing. I'm reading the credits and I'm dividing credits by 30, but I have a special case for 0. So for 0 could indicate a number of credits anywhere between 0 and 29. So the number of credits is actually 0, not just credits divided by 30 is 0, but the number of credits is 0. I'm going to set S to be new student. Otherwise, S is a freshman. I know new students are freshmen, but still, this is the way I'm encoding it. Okay, and then whatever the other values are, wherever I enter in the block, I just assign S a value, and then I break out. So if my number of credits were 31, credits divided by 30, 31 divided by 30 is 1. I enter at case 1, S is sophomore, then I break, and I exit the loop. So the point is, if you want to cover extra cases, sometimes it's easier to combine if statements within a switch. For example, if you want to cover a range of possibilities within a particular case. Okay. So, knowledge checks. These are the things you should know ahead of the exam, ahead of any quizzes. Number 1, be able to write and evaluate simple Boolean expressions, right? So if I give you a Boolean expression or some complicated arithmetic computation involving Booleans, then yeah, you should be able to, in the end, evaluate that and see whether it's true or false. Second, write and evaluate compound Boolean expressions with and, or, and not. And those will have to be syntactically valid. So remember, and uses ampersands, or uses the straight vertical lines, and not uses an exclamation point. Other stuff in the coding questions, be able to write and interpret if else, and switch statements. So you may have something simple to do there. For example, a method that receives an int, and depending on the range of values that it could contain, it returns one of various codes. Last, write and interpret nested if else, and switch statements. So I'll give a quick example. Suppose the coding question is write a method that accepts an int named x as a parameter and returns 7 if x is greater than or equal to 128, returns 6 if x is between 64, x is what? Greater than 64, but less than 128, returns 5 if x is greater than 32, but less than 64. Okay? And returns 4 otherwise. So, do something like this. Returns an int. The method could be called method, and accepts an int x. Okay? And so, different ways you could do it, but the simplest way to do it is just with ifs. So, if x is greater than or equal to 128, return 7. Okay? Else, if x is greater than or equal to 60, or is greater than 64, the way that's written, return 6. Else, if x is greater than 32, return 5. Else, return 4. Okay? And notice I don't have to cover the upper range of this in this case, because I know if x were greater than or equal to 128, I'd have already returned out of the method. So I just have to cover the cases that aren't covered by the previous line. Okay, and that'll do for now. I hope this helped.